Hello students. So in the last lecture we discussed about a stationary wave. Okay, chalo. So what is the equation of stationary wave? Stationary wave is given by what is the equation of stationary wave? 2a sine kx cos omega t. Okay, what is the meaning by what is the equation of stationary wave? 2a sine kx cos omega t. And in which case stationary wave are produced? When between two rigid support, if string is connected, then in that case stationary wave are produced. Okay, chalo. So now students, today we discuss nodes, antinodes and frequency of stationary wave. Okay, chalo. So first is what? Node. Chalo. So what is the meaning by node? Node means what? Where the amplitude of amplitude becomes 0. See, what is that amplitude here? Here amplitude is what? 2a sine kx. So where that 2a sine kx means amplitude becomes 0, then it is known as then that points are known as node. Okay, okay, point at which amplitude becomes 0 is known as node. See students, first of all, this is the suppose stationary wave. At both the end rigid supports are there. So now suppose students, see that point, this is what? Wavelength, total wavelength, and these are the nodes where the amplitude becomes 0. So see, what is that point? Lambda by 2 lambda. So that's are the what? Node. Okay, lambda by 2 lambda, then 3 lambda by 2. That's are the position of nodes. Okay, see here amplitude becomes 0, so this is total lambda, so this is half. So lambda by 2 lambda, 3 lambda by 2 2 lambda, that all are the position of nodes. Okay, so proof see what is the its proof? See here amplitude becomes 0, and what is the amplitude of, what is the amplitude? 2a sine kx. So sine kx becomes 0. So sine is kx is 0, where pi x is pi 2 pi. Here we cannot take 0 because it is the starting point. Okay, so we cannot consider starting point. After that, see from the starting point where the amplitude becomes 0, that's are the node. Okay, from the starting point where the amplitude becomes 0, that points are nodes. So in general we write what here? N pi, pi, 2 pi, 3 pi, 4 pi. At that point sine, trigonometric function sine becomes 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. So general we write n pi, where n is 1 2 3 4. So 2 pi by lambda, so pi pi cancel, so x is equals to n lambda by 2. Okay, x is equals to what? N lambda by 2. So students, when we place n equal to 1, when we place here n equal to 1, so we get lambda by 2. When we place n equal to 2, 2 cancel, so we get lambda. When we place n equals to 3, So we get 3 lambda by 2. Okay. But students તમને આમાંથી ડાયરેક્ટ ખબર પડી જાય. Okay, જો આપણે આવી ગયું તો lambda by 2 lambda. So what is the general position of nodes is given by x equals to n lambda by 2, where n is 1, 2, 3, 4. And what is the distance between two consecutive nodes? Lambda minus lambda by 2. So what is the distance between two consecutive nodes? Lambda by 2. Okay, what is the distance between two consecutive nodes? Lambda by 2. Chalo, so node means what, students? Point at which amplitude becomes 0, then that points are known as nodes. Okay, point at which amplitude becomes 0, then that points are known as nodes. Chalo, so these are the nodes. Now we discuss anti-node. Nodes means amplitude becomes 0. Now anti-node means what? Point at which amplitude becomes maximum. Okay, anti-node means what? Point at which amplitude become maximum. So point at which amplitude become maximum are known as anti-node. Okay, point at which amplitude become maximum are point at which amplitude become maximum is known as what? Node. Chalo, so see students, now what are that point? Chalo, see, suppose this is the complete lambda. So see here, that points are what? Antinodes. Okay, first we define nodes, now antinode. Antinode means amplitude. So this is the antinode, this is also antinode, where amplitude becomes maximum. So students, that distance is what? That is lambda by 2. That distance is lambda by 2, but this is again half. So this is what? Lambda by 4. Then this distance is 3 lambda by 4. Okay, lambda by 4, lambda by 4, 3 lambda by 4. So this distance is 3 lambda by 4. But how to obtain, students? See, how to obtain amplitude become maximum? So what is the amplitude? 2a sin kx, that become maximum. And what is that value? Plus or minus 1. In upside plus 1, downward minus 1. And where sine is plus or minus 1, pi by 2, then plus 1, sine pi by 2, 3 pi by 2, then minus 1, 5 pi by 2, then again plus 1. So see students, pi by 2 is common for all. Pi by 2 is common for all. Then 1, 3, 5, 7, odd number. So we write 2n minus 1. Why? Because odd number. So what is k? 2 pi by lambda. So 2n minus 1, pi by 2, pi cancel. So what is x? 2n minus 1 lambda by 4. What is x? 2n minus 1 lambda by 4. Where n is what? 1, 2, 3, 4 and so on. When n is 1, 1, 2, 3, 4 and so on. So that are the what? NT naught, where the amplitude become maximum. Okay. So now if we placed here 1, then 2 minus 1, so lambda by 4. If we placed here 2, n equal to 2, then 2 into 2, 4. 4 minus 1, 3. So we get 3 lambda by 4 C. Okay, then we placed 3, then 2 into 3, 6, 6 minus 1, 5 lambda by 4. So okay students, so what are the, in the case of stationary wave, what are the position of node? N lambda by 2 means lambda by 2, lambda, 3 lambda by 2. And what are the position of NT node? 2n minus 1 lambda by 4 means lambda by 4, 3 lambda by 4, 5 lambda by 4 and so on. Okay, so what is the, now we discuss, see here we find distance between two consecutive nodes, so that is lambda by 2. Okay, same here, now we want to find same, now here we find distance between two consecutive NT nodes. So we get what? 3 lambda by 4 minus lambda by 4, so 2 lambda by 4. So we get what? Lambda by 2. Okay, so what is the distance between two consecutive NT nodes? What is the distance between two consecutive NT nodes? Lambda by 2. Okay. चलो तो ये सेम છે સ્ટુડન્ટ્સ. ઇટ મીન્સ સી સ્ટુડન્ટ્સ કન્ઝ્યુકેટિવથી તમને બેનિફિટ શું થાય? જો સપોઝ ઇફ યુ નો ધ ફર્સ્ટ પોઝિશન ઓફ નોટ લેમ્બડા બાય 2, તો તમારે સેકન્ડ ગોતવું હોય તો અગેન એમાં શું એડ કરી દો? લેમ્બડા બાય 2. સો વી ગેટ સેકન્ડ નોટ, સેકન્ડ પોઝિશન ઓફ નોટ. if you want to more, then again add lambda by 2. So we again get the third position of node. So okay, so each and every time if we add lambda by 2, then we get more number of nodes. Okay, so same here. If we know the first position of node lambda by 4, then if you want to position of second NT node, then add what? Lambda by 2. Take LCM. So again, if you want to obtain third position of node, then again obtain lambda by 2. So we get 5 lambda by 4. Okay, so what is the distance between two consecutive nodes? Lambda by 2. What is the distance between two consecutive NT nodes? That is also lambda by 2. So now see one question, student. Stationary wave y is equal to 5 sin pi x by 3 and cos 40 pi t. Okay, and values are in centimeter. This y displacement is in centimeter. Chalo, we want to find distance between two consecutive nodes. Okay, we want to find distance between two consecutive nodes. Chalo, so see students, here we want to find distance between two consecutive nodes. Chalo, so see, what is the distance between two consecutive nodes? So distance between two consecutive nodes is what? Lambda by 2. Okay, distance between two consecutive nodes is what? Lambda by 2. So now students, we want to find distance between two consecutive node or anti-node. It is same, that is what? Lambda by 2. Okay, chalo, so here we want to find first lambda. So for k is equals to 2 pi by lambda, and what is k? Coefficient of x is k. Okay, kx. So what is the coefficient of x? Pi by 3, so it is k. What is the unit? Radian per centimeter. Now what is k? 2 pi by lambda. So lambda is equal to 6 centimeter. So what is the distance between two consecutive nodes? 6 by 2. Means what is the distance between two consecutive nodes? 3 centimeter. Okay. So distance between two consecutive nodes is what? 3 centimeter. Chalo, so we discuss position of node n lambda by 2, position of antinode 2n minus 1 lambda by 4. Node means amplitude becomes 0 and antinode means amplitude become maximum. And what is the amplitude for stationary wave? 2a sin kx. Now next students, we want to frequency of stationary wave. Now next we want to discuss frequency of stationary wave. Okay students, so now what is the meaning by frequency of stationary wave? See first, so see students, suppose what is x is 0 and this is L, means what is the length of string? Is lambda. Then from the opposite side, next reflected wave, here reflected wave is starting. So see students, we can say that at x equals to L, see how to get frequency. See at x equals to L means at here, wherever at x equals to L, what is the amplitude? Becomes 0. See at x equals to L, what is the amplitude? 0. Now what is the amplitude of stationary wave? 2a sin kx. What is the amplitude of stationary wave? 2a sin kx. But what is x? L. So here we write 2a sin k. Okay, we want to obtain frequency of stationary wave. So we know that at the end, because both the end are rigid support, so at one end wave start, at another end after that point reflected wave is starting. So we can say that at x equals to 8, again amplitude becomes 0. So what is the amplitude? 2a sin kx, but here x is what? L. Chalo, so sin kl is 0. As we know, See, with 0 and pi, 2 pi, 3 pi and so on. So we take what? N pi. So n is 1, 2, 3. Okay, so k is equals to what? 2 pi by lambda. See, we want to obtain frequency, huh? So k is equals to what? 2 pi by lambda is equal to n pi, pi cancel. So what is the length? What is the length of a string? આપણે યાદ રાખજો, what is the length of a string? n lambda by 2. ચલો, now આવી યાદ રાખવાનું છે. Now from that we can obtain the frequency. What is L? n lambda by 2. Now students, from this formula we can obtain the formula of frequency. See how L is equals to n lambda by 2. L is equals to n lambda by 2. So when students, how to get frequency? See, as we know, speed is equals to frequency into lambda. Speed of wave v is equal to frequency into lambda, nu into lambda. So lambda is equals to v by nu. Okay, students, confusion high, so you can write also f. Okay, chalo, so L is equals to n by 2. What is lambda? V by nu. So frequency nu is equals to n v by 2l, or otherwise you can write f is equals to n v by 2l, where n is what? 1, 2, 3. So students, what is the frequency for stationary wave? Frequency of stationary wave is given by n v by 2l. Okay, frequency of stationary wave is given by n v by 2l. And what is the length of a string in the case of stationary wave? Length of a string in case of stationary wave, that is given by n v by 2l, n lambda by 2, and frequency is n v by 2l. And what is v, students? Here waves on a string, so v is t by mu. What is the speed? Under root t by mu. Chalo, so this is the frequency of stationary wave. Chalo, so now again we obtain our fundamental frequency, first harmonic and so on. Chalo, so now we got the two formula. L is equals to n lambda by 2, and frequency nu n is equals to n v by 2l. Okay, frequency nu n, or you can write fn, frequency nu n is equals to n v by 2l. Chalo, now when we take n equal to 1, when we take n equal to 1, then what is the length? Lambda by 2. What is the frequency? v by 2l, and this is known as fundamental frequency. That is known as fundamental frequency or first harmonic. Fundamental frequency or first harmonic. Okay, chalo, so now how to draw this thing? See, it is only half wave. What is the length? Lambda by 2. So see, here only half wave is there. This is the incident, only half wave. See, this is the complete wave, but here only half wave. Okay, Here we draw only half wave. Why? Because length is lambda by 2. So this is incident wave. Now from that point, this is what? Reflected wave. Okay, and what is that length? Lambda by 2. Chalo. So now we take n equal to 2. Now we take n equal to 2. So now we take n equals to 2. So if we take n equal to 2, then what is the frequency? 2v by 2l. Okay, what is the frequency? 2v by first, what is the length? N lambda by 2, but n is 2. So what is the length? Lambda, complete wavelength. And what is the frequency? N equals to 2. Here n equals to 1. So n equals to 2, then 2v by 2l. Here n equals to 2, so 2v by 2l. Now see, v by 2l. V by 2l is becomes new 1. V by 2l is equals to new 1, means f1. So students, it is known as, see here 2 I so it is known as 2 on a new 1. So it is known as second harmonic and first overtone. And first overtone. Why first overtone? See students, now it is a one complete length. Chalo, so this is the incident wave, one complete. Now after that, here it is the what? Reflected wave. So see students, it cross one time. Okay, so it is known as first overtone, and see it is node and here antinode. So two antinode and one node. Two antinode and one node. Here antinode is only. Why? Because amplitude maximum. So here two antinode and one node. Where it cross, then it one at that point amplitude 0. So it is known as node. So it cross one time, so that is known as first overtone. It is known as first overtone. So now we take n equal to 3. Now we take n equal to 3. So what is the length? Here n lambda by 2. So what is the length? 3 lambda by 2 means 1.5 lambda. One complete wave and another wave is half. Okay, chalo. So and what is the frequency? Here we take 3. So what is the frequency? 3 v by 12, and v by 12 is what? V by 12 is new one. So it is known as third harmonic. It is known as third harmonic and second overtone. Okay, third harmonic or second overtone. Why second overtone? See, chalo, so here how many waves? Suppose this is the one complete wave and one more half wave. Okay, chalo. So now after that point we draw the reflected wave. Chalo, so students see, here 2 times cross means 2 times cross, so amplitude here 0, maximum amplitude, so 2 node and 3 antinode, 2 node and 3 antinode. So 2 time cross, so it is known as second overtone. Okay, 2 time cross, so it is known as second overtone. So students, see from the figure, when n equals to 1, it is known as fundamental frequency of first harmonic and no overtone. But when we take n equal to 2, then it is known as second harmonic. N equal to 1 is known as fundamental frequency or first harmonic. N equal to 2 is known as second harmonic and first overtone, because see, one overtone is there, એકવાર cross થાય છે. When n equal to 3, it is third harmonic and second overtone. So what is the general formula? Now we write frequency of stationary wave is Nv by 12, where nth harmonic and n minus 1 overtone. Means when n equals to 3, so what is the overtone? 3 minus 1, second overtone. Okay, so for overtone તમારે એક લેસ લેવાનું. તો તમને સ્ટુડન્ટ્સ કોઈ એમ કહે કે 9th overtone, then what is the value of n? તો તમારે શું લેવાનું? 9th overtone. overtone કેટલા હોય? n minus 1. so n minus 1 equal to 9. so we take n equal to 10. Okay, when n equal to 10, then overtone is what? 10 minus 1, 9th overtone. તમને એમ કહે કે 15th overtone, so we take what? n minus 1 equal to 15, so we take n equal to 16. n equal to 16, then we get 15th overtone. તમને એમ કહે કે 5th harmonic, then we get n equal to 5, because harmonic માં એવું છે, જો see, n equals to 1, then first harmonic, n equal to 2, then second harmonic, n equal to 3, then third harmonic. so harmonic 5th harmonic કહી તો n1, but overtone માં એક વધારે લેવાનું. તમને એમ કહી 6th overtone, so we can take n equal to 7. Okay, so our number of overtone is what? n minus 1. Chalo, so this is all about what? Frequency of stationary wave. Chalo, now we discuss its numerical. Chalo, see the first question from the textbook, that is question 14. First question from the textbook, that is question number 14. Exercise question number 14. A wire is stretched between two rigid supports. A wire is stretched between two rigid support. Suppose these are the two rigid support and wire is stretched between two rigid support. So it means here stationary waves are produced. Okay, here stationary waves are produced. A wire is stretched between two rigid support, vibrate in its fundamental mode. Vibrate in its which mode? Fundamental mode. So fundamental mode means fundamental frequency, so we equal to 1 with a frequency of 45 Hz. Why we write here F1, students? Because fundamental frequency n equals to 1, then it is known as what? Fundamental frequency. Okay, so that's why here fundamental mode is given, so we write F equal to 1, F1 and n equal to 1. Chalo, mass of a string is 3.5 into 10 raised to minus 2 kg. And linear mass density of wire, linear mass density means mass per unit length. Linear mass density of wire is 4 into 10 raised to minus 2 kg. Chalo, so first of all, how to know here waves are stationary wave? Because wire is stretched between two rigid support. Okay, so stationary wave are produced. Now students see we want to given its fundamental frequency, and here we want to find, first of all we want to find speed, and then we want to find tension in a string. Okay, T is tension. So see, what is the frequency? Fn is equals to Nv by 2L. N is 1 because fundamental mode. So V by 2L, we want to find V. So 2L F1, we want to find V. So 2L F1, F1 is a fundamental frequency, or F1 is a fundamental frequency or first harmonic. Sorry, now see students, F1 is given but length is not given. That is our problem. Length is not given, but see, linear mass density is given. So what is the linear mass density? M by L. So L is equals to M by mu. Okay, linear mass length is not given, but linear mass density is given, and from that linear mass density we want to find length. Mu is equals to M by L. So L is equals to M by mu. So L is equals to M by mu. What is mass? What is linear mass density? What is F1? 45. Chalo, so what is the answer, students? 2 into 3.5, so it is 7. Then 7 into 45, 315 divided by 4. So we get round up 79. So what is the answer? 79 meter per second. So we get the what? Speed. Now we want to find tension. So V is equals to under root T by mu. Okay, because what is the formula of speed of wave on a string? V is equals to under root T by mu. So V square is equals to T by mu. So T is equals to tension, T is equal to V square into mu. Tension T is equals to what? V square into mu. What is the speed? 79. What is mu? Linear mass density 4 into 10 raised to minus 2. Chalo, so what is the tension? 249 Newton. What is the tension? 249 Newton. Okay, chalo, so that is the question or frequency of stationary wave. Chalo, now see the next, students. Chalo, see what is the equation of stationary wave. Equation of stationary wave is given by y is equals to .5 sine 1.57x 1.57x and cos 3.14t. Okay, and that y is in centimeter. Chalo, so length of string is 10 centimeter. We want to find number of loops. Okay, we want to find number of, it is a stationary wave, a length is 10 centimeter and we want to find number of loops. Options are 2, 1, 4 and 5. Okay, what are the options? 2, 1, 4, 5. We want to find number of loops. Chalo, so see students, how to find number of loops here. See, first of all, see when n equals to 1, so see here n equals to 1, so how many number of loops are there? One loop. Here n equal to 2, this is for n equal to 2, so how many number of loops? 2, 1, 2, and here n equal to 3, so how many number of loops? 1, 2, 3. Okay, so number of loops means what? We want to find n. N is also known as number of mode. So here we want to find n. Number of loop means what? N. Clear? Because when n equals to 1, 1 loop, n equal to 2, 2 loop, n equal to 3, first, second, third, 3 loop. Chalo. So number of loops means what? Here we want to find n, and length is given, students. What is the length? 10 centimeter. What is the length? 10 centimeter. So length is given, students, and what is the formula of length? N lambda by 2. Okay, we use, because frequency is not given, students, but length is given. And what is the formula for length in the case of stationary wave? Length is what? Length is what? N lambda by 2. Length is n lambda by 2. See students, if you know the formula of length, so we can also obtain from the frequency. Frequency is equals to nv by 2l. Then what is the speed? Frequency into lambda. So frequency is equals to v by lambda. So frequency is not given, so we place the value of frequency. So also we get the answer. Okay. We cancel. So what is the length? N lambda by 2. Sure. So see, if you first find the wavelength, how to find wavelength from the k, and what is k? 1.57. Okay, coefficient of x is k, so k is 1.57 and unit is radian per centimeter, because all are in centimeter. So k is equals to 2 pi by lambda. So 2 pi means 3.14, divide by, take lambda as a subject, so divide by 1.57, so 2 into 2, 4, So what is the wavelength? 4 centimeter. Length is also in centimeter, so no need to convert. Length is also in centimeter. We want to find n. So how many number of loops? 5. Okay, how many number of loops are there? Total 5 loops are there. Sure. Now next students see, next we discussed two types of organ pipe, closed and open organ pipe. So organ pipe means sound, in which sound is produced, students. So as we know, in the organ pipe, in case of organ pipe closed and open, sound is produced, so that are known as longitudinal stationary wave. Okay, they are known as what? Longitudinal stationary wave. First we discuss closed pipe, then we discuss open pipe. So first we discuss closed pipe, then we discuss open pipe. So students, what is the meaning by closed pipe? Closed pipe, in the case of closed pipe, one end is closed and other end is open. Okay, in case of closed pipe, one end is closed and other end is open. And at closed end, see, this is the closed pipe, and students remember that at closed end node is formed, and at open end open end anti-node is formed. At closed end node is formed and an open end anti-node is formed. At closed end node and at open end anti-nodes are formed. Okay, at closed end node and at open end anti-nodes are formed. Always remember, at closed end node and at open end anti-nodes are formed. Okay, one end is closed, other end is open. At closed end node and at open end anti-nodes are formed. Okay, students. So now next we discuss the now if you want to find this length of pipe, students, what are the example of closed pipe? In closed pipe, one end is closed and other end is open. તો એવું કયું સાઉન્ડ ઇન્સ્ટ્રુમેન્ટ છે? ઓર્ગન પાઇપ એટલે સાઉન્ડ ઇન્સ્ટ્રુમેન્ટ. તો એવું કયું ઇન્સ્ટ્રુમેન્ટ છે કે જે વન એન્ડ ક્લોઝડ હોય, અધર એન્ડ ઓપન? તો કે વિસલ. વિસલ લ્યો તો એનો એક એન્ડ ક્લોઝડ હોય, એક એન્ડ ઓપન હોય. સો વિસલ ઇઝ અ એક્ઝામ્પલ ઓફ, એવું તમને ઘણા બધા યાદ આવશે. સો વિસલ ઇઝ અ એક્ઝામ્પલ ઓફ closed pipe, closed organ pipe, at closed and non, at open and anti-non. So if you want to find students length of pipe, if you want to find length of pipe, then we want to find distance between node and then we want to find what? Distance between node and antinode. Then we want to find what? Distance between node and antinode. Chalo, so what is the first position of node, students? Lambda by 2. Okay. What is the first position of antinode? Lambda by 4. See, what is the first position of node? Lambda by 2. And what is the first position of antinode? Lambda by 4. Chalo. So lambda by 2 minus lambda by 4, so we get lambda by 4. So students, હવે lambda by 4 પછી next node antinode માં 3 lambda by 4 જ આવે. Okay, so now see, after lambda by 4 we get what? After lambda by 4 we get 3 lambda by 4, we get 5 lambda by 4. So what is the general? 2n minus 1 lambda by 4. હું તમને ડિરાઈવ કરાવું છું સ્ટુડન્ટ્સ, પણ તમે ડાયરેક્ટ યાદ રાખજો આન્સર. સો વોટ ઇઝ ધ લેન્થ ઓફ પાઇપ? 2n minus 1 lambda by 4. But students, we want to obtain frequency. So frequency is what? Speed is equals to frequency into lambda. You can write nu also. So lambda is equals to what? V by 4. So 2n minus 1 by 4 as it is. In place of lambda we write f by v. So what is frequency? 2n minus 1 v by 4. What is the frequency? 2n minus 1 v by 4. Okay, so this is for organ pipe, means sound instrument. Organ pipe means sound instrument. 2n minus 1 v by 4. This is the frequency for closed pipe. Chalo, now see, what is the frequency? 2n minus 1 v by 4. What is the frequency? 2n minus 1 v by 4. If we take n equal to 1, then we get v by 4l. If we take n equal to 1, then we get v by 4l. If we take n equal to 1, then we get v by 4l. Now it is known as what? It is known as first n equal to 1. So 2 minus 1. So 1. So v by 4l, it is known as first harmonic or fundamental frequency. It is known as first harmonic or fundamental frequency. So now if we take n equal to 2, if we take n equal to 2, then we get what? 2 into 2, 4. See, n equals to 2, placed here n equals to 2. So 2 into 2, 4, 4 minus 1, 3. So we get 3v by 4l. So we get what? 3v by 4l. Now see students, v by 4l is what? v by 4l is f1. So students, see અહીંયા 3 આવે છે, so it is known as third harmonic. અને આપણે હમણાં જોયું હતું n equal to 2 હોય તો એને તમે શું કહી શકો? ફર્સ્ટ ઓવરટોન. કેમ આપણે આને થર્ડ હાર્મોનિક કીધું? બીકોઝ અહીંયા 3 છે. સો if we take n equals to 3, if we take n equals to 3, then what? f3, 2 into 3, 6, 6 minus 1, 5v by 4l. And v by 4l is what? f1. So here we get 5f1. So students, it is 5. So it is known as fifth harmonic. Or n equal to 3. So second overtone. તો સ્ટુડન્ટ્સ આમાં હાર્મોનિક જો ઇવન હાર્મોનિક આવતા જ નથી. First harmonic, third harmonic, fifth harmonic. So in case of open pipe, only odd harmonics are present. Okay. So what is the general formula? 2n minus 1 v by 4l. So 2n minus मतलब આમાં જે odd frequency present હશે, even નહીં આવે. 2f1 એવું નહીં આવે, 4f1 એવું નહીં આવે, f1, 3f1, 5f1, only odd harmonics are present. So 2n minus 1 harmonic and overtone same, n minus 1 overtone. Okay students, so always remember in case of closed pipe only odd harmonics are present. So suppose 15th harmonic, then what is n? 15th harmonic, and what is how many number of harmonics are there? 2n minus 1. So 2n is equals to 16, then we take n equal to 8, then we get what? 16th harmonic. Okay. Suppose if we want to find 9th harmonic, then what is n? So 2n minus 1 equal to 9, because 9th harmonic. So 2n equal to 10, so n equal to 5. Suppose if you want to find a value of n for 10th harmonic, so 2n minus 1 equal to 10. So see, n equals to 11 by 2. This is not possible, because in case of organ pipe, even harmonics are not present. 10 is even harmonics are not present. Okay. So always remember students, in case of closed pipe, યાદ રાખજો સ્ટુડન્ટ્સ, હું તમને એક ટેબલ એ બનાવું છું હમણાં. So in case of closed pipe, odd harmonics are present. Chalo, in closed pipe, odd harmonics are present. Chalo, so now open pipe. ચલો સ્ટુડન્ટ્સ, ઇન કેસ ઓફ ઓપન પાઇપ બોથ એન્ડ્સ આર ઓપન. સો આવું કયું સાઉન્ડ ઇન્સ્ટ્રુમેન્ટ છે સ્ટુડન્ટ્સ? દેટ ઇન કેસ બોથ એન્ડ્સ આર ઓપન, સો દેટ ઇઝ ફ્લૂટ. ઓકે, વાંસળી, ફ્લૂટ. તો એ શું છે? ઓપન પાઇપ. ઓકે, સો ફોર ઓપન પાઇપ both for open pipe, both ends are open. For open pipe, both ends are open, and at both open end, NT nodes are formed. Open end तो क्यों होय NT nodes. At both open end, NT nodes are formed. See students, at both open end, NT nodes are formed. Okay, so if you want to find length of pipe, then we want to find distance between open end to NT node. બંને end open છે તો બંને end માં NT node. So if you want to find length of pipe, length of open pipe, then we want to find distance between two NT node. तो NT node ની પોઝિશન શું હતી? λ/4, 3 λ/4 है ना. So what is the position of NT node? λ/4, 3 λ/4, 5 λ/4. So we get what? Distance between two NT node. So length of pipe means distance between two NT node. So 3 λ/4 minus λ/4. So 2 λ/4. So λ/2. Students, λ/2. Then what is the general formula? See, λ/2, 3 λ/2. Then what is the general formula? N λ/2. So here we get N λ/2. Okay, chalo now again speed formula. Speed is equal to frequency into lambda. So lambda is equals to speed by frequency. So what is frequency? NV by 2L. What is frequency? NV by 2L. So students, the answer jo, this is the same answer like stationary wave. This is the same answer like a stationary wave. NV by 2L. So see students, frequency of wave in a stationary, frequency of stationary wave, and frequency for closed pipe, open pipe are same. Open pipe અને સ્ટેશનરી વેવ ફ્રીક્વન્સી સેમ છે. ઓકે, NV by 2L. તો અલગ કોણ થયું? ખાલી ઓપન ક્લોઝ પાઇપ. શું આવે છે ક્લોઝ પાઇપ માટે? 2N - 1 V/4L. બટ ફોર open pipe and for the stationary wave, frequency is same, NV by 2L. Chalo, so this is the same answer here. We write like a stationary wave, nth harmonic and n-1 hour. Okay, this answer is same like a stationary wave. Chalo, so for open pipe, for closed pipe, and for stationary wave. So stationary wave, closed pipe. Here it is that अभी closed pipe में अभी wave मॉडल is stationary है, but that are for sound. Here we consider sound wave, and here we consider waves on a string, right? Because closed and open organ pipe are sound instrument, and this is what open pipe. Again here we consider sound wave. Chalo, so first students see here what is the formula. First we write that NV by 12, NV by 12, nth harmonic n minus 1 over 2. Same here, nth harmonic n minus 1 over 2, and here 2n minus 1 v by 4. So again here, but see students, in that case only odd harmonics are present, so 2n minus 1 is odd, or a 2n minus 1 harmonic, and overtone are same in all case, n minus 1 over 2. So this is the stationary wave, means waves on a string, closed pipe and open pipe. Okay. So students, now in next lecture we discuss the MCQs related to this topic.